Good morning. My name is Jirathik. I am from CSC sales section. My roll number is 219518005G2. Today we are going to see AD. My topic is the switched capacitor integrator. The switch the capacitor integrator. What is an integrator? Energy efficiency, mobility, and green technologies are driving continuous innovations in power device development. A broad range of green applications are pushing switching power amplifiers towards more extreme operating conditions, impacting everything from simple diodes to lateral and vertical MOSFETs, silicon and silicon carbide, IGBTs, and gallium nitride JFETs. Higher voltages, frequencies, and temperatures required increase products quality and reliability. Yields are challenged by increasingly complex processes, novel materials and substrates, and application-specific packaging designed to dissipate heat more efficiently. Fault localization of integrator devices. Integrator pose unique challenges for localizing faults, primarily as a result of power device architecture and layout. Unlike logic and memory technology, which use very large-scale integration of tiny transistors, power technology is based on the single transistor covering up to hundreds of square millimeters, connecting diodes and discrete devices. The switching power topology creates a needle in the haystack scenario for defect detection, whereas integrated circuits are equally susceptible to opens and shorts. Power device reliability in generally associated with short circuits under high voltage and high current conditions. A small leakage part in power device can quickly cascade into a catastrophic failure as performance demands increase and power technologies advance. Power device manufacturers and their customers need tools that quickly pinpoint fault locations at operating conditions. Subsequent characterization of materials, interfaces, and device structures require precise, high-throughput analysis. Detecting and localizing a leakage path before it becomes a dead shot and critical to meeting reliability standards. Metal bridge or a particle or even a weak spot in the gate oxide. Localizing a small leakage current under a micron thick sheet of metallization is not a trivial challenge. Accurately localizing the defect to ensure its successful physical characterization is even more challenging. Methods and techniques that works for logic and memory devices won't necessarily work for proper power devices. Switch capacitor integrator. Wide band gap semiconductor devices are composed of materials with a larger energy band gap than typical semiconductor materials like silicon, gallium, arsenide. The inherently allows them to operate at high voltages, currents, and frequencies, making them ideally suited for power applications. Currently, band gap power devices composed of materials such as silicon carbide, and gallium nitride are being used in a variety of power applications, including electric hybrid vehicles as well as in energy storage and distribution industries. Further research and optimization of these materials necessitates high resolution analysis and characterization to meet the device performance, safety, and quality requirements of these markets. Thermo, Thermo Fisher Scientific offers multiple failure analysis workflows optimized for the unique challenges challenges of power devices. Follow the links below for more information on characterizing current voltage behavior, detecting leakage currents, and analyzing materials and processes in modern power devices. In a world with an increasing penetration of wide band gap semiconductor technology, semiconductor technology, the FEPCON 2015 section is new power devices and high temperature focused on power semiconductor devices and passive components up through integration for the purpose of refining appropriate power electronics converts by 2025. And import goal was to identify those markets and applications where silicon technology which remain the preferred. Thus, higher power densities afforded by using using WBG semiconductors require those passes capable of operating at high temperatures and having high reliabilities. Presenters addressed the state-of-art and future directions of magnetic cores, dielectric materials, and electronic packaging integration. The semiconductors are rarely the predominant failure mechanisms. Even in silicon modules, the failure mechanisms are usually either the passive components or the packaging. Finally, potential additional frontiers that merit research in WBG world, such as new markets, capabilities, circuit architectures, and applications, were evaluated. The section was divided into four main groups: WBG technologies, silicon technologies, passive technologies, and power integration technologies. Thank you.